Alright, in this video I'm going to do kind of a complicated example involving the law of sines, and I didn't want to write up all the words because it's kind of a long problem, so I didn't write the whole words to it. I kind of drew the picture up here, but I'm going to read the problem to you. We have a bird perched on top of a pole on a steep hill, right? So there's a steep hill, there's a pole on the top, and there's a bird sitting on top of the pole. I did not draw the bird. And an observer is located at point A on the side of the hill 110 meters downhill from the base of the pole. Right, so here's the point where the observer is, looking up at that bird on the pole, and that person's 110 meters from the base of the pole on the top of the hill. The angle of inclination of the hill is 50 degrees. So from the horizontal, the angle of the hill is 50 degrees, and the angle alpha is 9 degrees. So the angle here, basically the angle of inclination of the observer from the hill up to where the bird is a 9-degree angle. And we want to find the distance from the observer to the bird. So we want to find the length of this dotted line here, the distance between the observer and the bird. All right, so let me mark that with an X. That's what I'm trying to find, is the length of that dotted line. Right, so, looks pretty complicated, right? I need to find this length here. I know some stuff. I know this angle down here, and I know this side. But that's not really enough for me to use the law of sines, right? Remember, the law of sines, I need to know one side and its opposite angle, and then any other bit of information about the triangle. Well, I know this side over here of this triangle that's like on top of the hill, like between the hill, the pole, and the line of sight of the observer. For that triangle up there, I know this side is 110, but I don't know its opposite angle, which would be the angle up here, right? So I don't know that. I know this angle down here, right? But I don't know its opposite side, which would be the length of the pole, and so I don't have enough information there to set up my proportions to do my law of sines. And if you haven't seen the other videos that I've done on the law of sines, I did one where I explained just the formula for the law of sines and what that means, and I did another one where I did a couple examples. So if you've seen those, you should realize here that we can't use the law of sines as this stands now. We don't have enough information to set it up. Right, so somehow we need to discover some more information that we can use to solve this problem. And you might want to read through the problem again, but when you do, you'll realize that we didn't miss anything. This is all they're telling us. All right, so for a problem like this, and for a lot of these trigonometric problems, especially some of these more complicated types of word problems, sometimes you have to draw extra stuff in the picture. Sometimes you have to create more triangles in order to be able to get all the information you need to actually solve the problem. So here's what I'm going to do for this one. I'm going to take this pole that's vertical going straight up and down. I'm just going to extend that line down to this horizontal line down here, and that's going to form a right angle, and that forms a right triangle, right? With the horizontal, the vertical, and then the slope of the hill, that now forms a right triangle, right? And I know that this angle of the triangle is 50. I know that this one is 90, which means I can figure out what that angle in the top of that new triangle that I formed is, right? All three of those have to add up to 180. Right, so if I do 50 plus 90, that's going to be 140. Right, and then if I do 180 minus 140, that gives me 40. All right, and many of you probably could have done that in your heads and know that that angle up there is going to be 40 degrees. All right, so now I know that this angle at the top of this new triangle that I created by just kind of extending that vertical line there, I know that that angle is 40 degrees. Okay? So what does that help us with? Well, that angle is not part of this other triangle that I really need to work with, because I need to know the length of this side of this triangle that's like above the hill. So how does that help? Well, it actually does help, right? It does, because I have a vertical line here, right, from the dotted line here and then the pole up on top of the hill. That makes a vertical line, and if you recall from geometry, the angle of a vertical line is 180 degrees. Right, so if this side is 40 degrees, this side has to be 140 degrees. All right, because 40 plus 140 equals 180. All right, so now if I kind of draw this triangle separately from the rest of all the stuff we have here, there's my line of sight to the bird, here's my pole, and then here's my slope of the hill. Right, I know that this angle here is 140 degrees. I know that this side here is 110 meters. And I know that this angle down here is 9 degrees. And I'm looking for this side over here, X. Alright, so still not quite what I need. It's good that I have this 140 degrees here for this angle, because the X is the side opposite that angle. All right, so that's going to make up one of my fractions in my law of sines. Is going to be the sine of 140 degrees over that side, x. But I need to know the angle opposite the other side that I know, which is 110 meters. All right, so I need to know that angle up there, but I can figure that out because now I know two of the angles in this triangle, right? I know the 9-degree angle here and the 140 there. So if I add those up, right, 140 plus 9, I didn't really need to write that down. That's 149 degrees. And then I do 180 minus 149, and that's going to give me 31. All right, so this angle up here, I now know is going to be 31 degrees. All right, so now I know all three angles of my triangle, and I know one of the sides. Now I can use the law of sines to solve for whichever other side I want to find, and I want to find the side that's marked up here with an x. Right, so for a problem like this, it's a whole lot of work before you can even get into the trigonometry of, okay, let's use the law of sines to solve for the side of the triangle that we're looking for. There's a lot to it just to get to that point. Right, so again, you'll see this as you do more and more problems. You'll probably see some challenging ones where you're not given all the information you need from the start, and you have to somehow do something to get more information. And the way you do that a lot of times is just draw an extra triangle, extend a line somewhere to create another triangle. Try to create a right triangle if you can. Try to make that a right angle. So if this is horizontal and I draw a vertical line down, that's going to make a right angle. And now I can say, okay, so 50 and 90, this one's got to be 40. All right, this is a straight line, so if this angle is 40, this one's 140. And now I know these two angles, so I can find that one up there. And now I have all the stuff I need in order to move on. Right, so if you're ever sitting there with a problem and you're like, oh, dude, I don't have enough information, I don't know what to do, start drawing extra lines and start doing something. And the first thing you do might not always work, but just try something. Like, well, what if I draw a line through here? Oh, that makes this triangle. Can I figure anything out from that? If it doesn't, erase it and try to do something else. Try to draw a line somewhere else. And if you keep trying things, you'll eventually hit on the one that gives you the information you need, and then you can proceed with the problem. All right, but anyway, once we've got our triangle set up, that was really the most challenging part of this problem. Right? Once we have the triangle set up, now it's just like those other examples that I did on those other videos. I just need to set up my law of sines and solve this. Right? So the first fraction is going to be the things I know. So it's the sine of 31 degrees over 110 meters. All right? So the sine of 31 degrees over 110 equals, and then I'm going to do the sine of 140 degrees over the missing side I'm trying to find, which is x. All right, so that's how I set it up. Remember, to set up the law of sines, I need one side and its opposite angle, the 110 and the opposite angle of 31. That makes up one of my fractions. And then, if I'm looking for a side, I need to have the sine of the angle opposite that side. So if I'm looking for side x, I need to take the sine of that 140 degrees. All right, and then once I have this set up, it's just cross-multiplying and solving. Right, so I cross-multiply, the x comes up here, the 110 over there. So it's going to be x times the sine of 31 degrees equals 110 times the sine of 140 degrees, and then to solve for x, I divide both sides by the sine of 31 degrees. Right? And when you're doing this work, like when you're using the law of sines to solve for a side, these algebraic steps here are always the same steps. You just have different numbers for the angles and the length of the side. So when you're doing that, just be careful that you are keeping everything organized. You're putting the correct angle number on the correct side of the fraction. The easiest mistake people make, or the common mistake people make, is putting like the 140 here and the 31 over there, just not paying attention and just putting it in the wrong spot. So just be careful for things like that. Pay attention to those little details. If you can set it up correctly, it's not so bad from there. Like I said, it's basically the same thing each time. Right, so x is going to equal 110 times the sine of 140 degrees divided by the sine of 31 degrees, and I probably, before I hit enter, check that my calculator is in degree mode, which it is. So here's what I type in: 110 times sine of 140, close parentheses, divided by sine of 31, hit enter, and I get 137. So I get 137.28. So let's call that distance x about 137.3 meters. Right, because our measurement on that side was meters, so we're going to keep that same measurement. All right, so this observer is about 137 meters in a straight line distance to that bird on top of that pole. All right, so next time you're out walking on a hill and you see a bird on top of a pole, you can definitely figure out how far away you are from that bird, because obviously that's the thing that you're going to be thinking about when you're in that situation, right? But that's how we solve this problem. Sometimes you do have to draw extra lines in your diagram. You have to create extra triangles so that you're able to, figure out angles and other things like that. Try to create, right angles. Try to create straight lines like we did here, so you know that they add up to 180, or the right triangle. All things that you should look for if the original problem does not give you enough information to solve it, right? It's pretty rare. I mean, sometimes teachers make mistakes and they just give you a problem that you can't solve because you don't have enough information. But if you're doing a problem out of a textbook or something like that, it's pretty rare that they give you a problem that you just can't do, right? It might look like it at first, like, well, they didn't tell me enough. But if you try doing some extra stuff like this, you should be able to figure it out.